This video is about nuclear equations and balancing them. It's a topic I know from years of teaching it people struggle with, but there's really no need to be worried about it actually. It's quite straightforward. You need to know, first of all, what an alpha particle is, its charge and mass, what a beta particle is, its charge and mass, and incidentally, if you're asked about gamma decay, know that that isn't a particle, it doesn't enter into this kind of thing at all. Beyond knowing those two particles, you otherwise need to just be able to add and subtract and read the periodic table, so it's not that taxing. The principle to apply is that mass and charge is conserved. So if you've got radium here with a mass of 226 and a charge of 88, that will appear in total on this side as well. So now we know alpha is 42, it's got to add to 226, so this number must be 222. Likewise, this has got to add to 88 to be maintained, so 86 plus 2 will work. Then you look up element number 86 on the periodic table and it's radon and it's done. Likewise, another example, okay, we've got an isotope of carbon, it's slightly heavier than normal, 14.6. It's undergoing beta decay and that's where you can get caught out, all right? Don't be tempted to take away 1 and get 5. We're taking away -1 to get 7. These two now, 7 and -1 adds to make 6, just checking that's right. The 0 means no change here. 14 is going to remain 14. Again, they add up and they equal. And look it up on the periodic table. If you don't remember what number 7 is, it's nitrogen. Done. It's pretty straightforward actually once you get used to it. Practice it a few times. Practice it on the question you're about to see. Good luck with that and thanks for watching.